Hi there. So I wanted to give an overview of how you can set up your own personal perforce server and run it off an SSD drive. Now, if it's a portable drive like this one, you can throw it in your backpack, plug it into another computer, and still have access to your perforce server without incurring the costs of hosting it in the cloud. So before we get started, let's actually have a look at this in action. So I'm going to start up an instance of Windows PowerShell, and this is typically what I do is I'll run Docker. Now, if you don't know what Docker is, it's basically a way to containerize your application. So as an example, let's say I made a Python application. I'm using a specific version of the language, a bunch of packages, and I want to run it on Ubuntu. Well, I can package all of that up, the environment, the operating system, everything, into a container, and then deploy my application as a single unit. I can deploy that container to another computer, and if it's running Docker Engine, it'll load and run just as it would on my machine. So it's really great. So that's what I'm doing here. I'm basically running Docker, and what you need to do is you need to install Docker Desktop. Once you have it installed, it sits in your taskbar here, and you can switch between Windows containers and Linux containers and do some settings. But I have Docker. You can also run it from the command line, which is what I'm doing here. And basically, I'm going to run an interactive terminal of this particular image here, which I've built. Now I've installed perforce on Ubuntu version 18, and so that's what I'm going to be running here. I'm going to open a port 1666, and it's bound to this particular volume, which is on my SSD drive, my F drive here, which is P4 root, and it's going to be an interactive terminal. So if I hit enter, just give it a second. I don't know what's up with PowerShell lately, but now I'm inside of Ubuntu. So if I do a version here, you can see I'm on Ubuntu 18, and I can do all of the commands there, do whatever I want. So now what I can do is start my perforce server, and I can load up P4V, and I'm connecting to my local host here. Click yes, the password, and there you have it. I'm connected to perforce. Here's my MicroPax workspace where I've been working on my jellyfish and stuff. But this is all running off of this SSD drive here. Well, Docker Desktop, and my database files are stored in P4 root on my SSD drive. And I can, in theory, just take it to any other computer, and as long as Docker Desktop is installed, I can run this server. So let's look into some of those details here. Now, if I want to shut down my server, it's the opposite. And then I can exit this Ubuntu container, and I'm done. I'll just exit the terminal there. So let's talk about, before we get to the actual Docker file and implementation details, let's just talk about some of the reasoning about why I would want to do this. So the idea stems from, okay, I want to run a perforce server. Typically I run or I store all of my projects on GitHub, but I don't use GitHub in any kind of collaborative manner because, I'm just working by myself. I just use GitHub or Bitbucket lately as just a dumping ground for my project, and since I'm not collaborating with anybody, I don't need to use LFS or any kind of file locking or setup. But I don't like Git as much as I do perforce. I think perforce is easier to use and better in many ways compared to Git. And when I was thinking about running a perforce server, my initial thought was, okay, well, I use AWS in my day-to-day, so at work. So, that's was my first thought. Oh, I'll just host a perforce server on AWS. So then if you do a search for the AWS pricing calculator, you can come here and you can do EC2 configuration. Now, the actual instance, an instance is basically a EC2 computer. Now, the actual instance type, I'm not really too concerned about because you can select one of their micro or free tier ones, and it's fairly cheap. Although, you're fairly limited. It's one virtual CPU and 1 GB of memory. But if you're just running a personal server, that should be more than enough. The free tier is free for about a year, I think. Don't quote me on that. You'd have to look into it. But what really concerned me is not so much the price of running the instance, because you can always stop an instance and start it to save money. The real cost that concerned me was the storage. So this elastic block storage here, general purpose SSD, 100 gigabytes of memory here is about $10 USD. So how about 120 US dollars a month? Now, that is maybe not enough for me. I'm thinking, I don't know, for 100 gigabytes, I don't know. I've seen Unreal Engine projects that are well over 300 gigabytes. I know if you build the engine, I'm not sure. I haven't done it lately, but I think it was like 160, 170 gigabytes. But this SSD that I purchased it's 1.81 terabytes. So if I switch this over terabytes, and that is 185 US dollars a month. And for this poor Canadian, that's $242. So that's too rich for my blood. So I think cloud hosting is still prohibitively expensive for the average user. So rather than spending this kind of money every month, and this is not including, what if I want to take a snapshot and back it up to an S3 bucket? That hasn't been calculated in this. Egress charges, so data coming out of the server, although that's, pretty minimal. This is just a rough estimate of what it could cost you. And what it is going to cost you is several hundreds of US dollars a year to run a personal server, I think. There are competitors to AWS. That would be DigitalOcean. It's another good provider that I've used. It's pretty good, but similar prices. So the idea that I came up with was, okay, well, what if I just go and buy myself a 2 terabyte SSD? And this is the one I settled on. It's a pretty good drive by Samsung. As you can see, 2 terabytes, and it's like 380 bucks plus tax. I think it was like 450 or something. Yeah. So what would be the advantage of doing this and running it via Docker? Well, the idea was, I kind of get the best of both worlds here. You could run your perforce server completely local, and in this case, it would be off a Windows machine. But then when it comes time to migrate the server, then I probably have to set up a Windows server, which I don't know anybody who wants to do that, although I hear good things about Azure. But I would like to keep things on Ubuntu. I like Linux, and the cost is free, right? So the other aspect of running a local server too is you gotta open a port in your router. So say if I wanted to collaborate with somebody, I could certainly do that as well. And I can do that with running the server off this SSD drive. I could open a port on my router and work collaboratively. But I could also, because it's running on Docker and I have my perforce server in this container, I can take that container and then just run it in the cloud on a computer with Docker. So in the future, if I wanted to move it into the cloud and collaborate with others, I could certainly do so. So I just kind of like having that option available to me. But I do like having the ability to basically take my server with me anywhere I want to go as well. So if I switch computers in the future as well, like this computer is getting kind of old, I upgrade my computer. Well, I don't have to reinstall the server. I just plug in my SSD drive and go. So that's kind of the idea there. So let's actually have a look at it. And another thing you might want to get set up is Windows Subsystem for Linux. If you do a search for that, you can install WSL2, and it'll walk you through the installation setup of a version of Ubuntu on your machine. Now, you're going to need Windows 10 Pro. If you have Windows 10 Home, it's not an option, I think. And this is kind of cool, too, because you basically have a version of Ubuntu running here. So here I have Ubuntu 20. And you can do whatever you want. Looks like I have a type map here. Let me copy that to the clipboard in case I need to set it up. But what I wanted to show you was Visual Studio. So if you type code and then the current working directory, it's pretty neat. Visual Studio Code is, I still have an instance of this Windows Subsystem for Linux here. So I can look at it, add it there. And rather than editing a file using Vim or something, I can actually come in here to this type map and just edit it inside of Visual Studio. So that's kind of cool. And I have my Docker files in there as well here. So I've got this Docker file. This is where the magic happens. So a Docker file is basically a recipe for building a Docker image that you then run. So here you can see I base it off of Ubuntu, a specific version number. You could probably upgrade that in the future. And then I run an apt-get to update and install a couple of packages here, including curl and vim. Then this gets rid of this annoying device warning. And I go and grab a perforce public key before installing the perforce repository, because then what I need to do is run Helix P4D, which is the package provided by perforce. And they have a configure P4D shell script that you can run. And you can go through it interactively, but here, obviously, because I'm building an image, I just kind of want to pass parameters to it. So this is important, specifying all zeros as the IP, and then you can give it your username and this amazing password of foobar42, whatever you want. And the last thing here is just a time zone. Since I'm on the West Coast, I wanted all the timestamps in perforce to reflect that. So with this recipe for how to build a perforce Docker image, again, it'll download perforce, run the installer, set up a bit of time zone stuff, make sure I've got whatever packages I want, and I'm ready to go. The next thing to do would be to build the image, and I can do that simply by right-clicking and selecting Build Image. Now that only works because I have this Docker extension installed for Visual Studio, so you might want to grab that as well. So if I do that, and you just give it a name, I'm just going to call it foo 18.04. The 18.04 is the tag on it. You can specify whatever tag you want, and it's done. Now, the only reason it's done so fast is because it used a lot of cached files here. So when you run this the first time, it'll take a while as it needs to grab the latest packages and install everything. Not too long. I'd say maybe about 5 minutes. But then once it's done, it's inside of the Docker images here. You can see that it was built. I can remove this because I don't want it polluting my images, because I already have one built. And the one I've built previously, about a month ago, was called P4D Ubuntu, and that's kind of what I ran. Now I can run it here, or I can, as I did before, is I run it right here. So after you build your image, that's where you would specify this particular image name. and the port and the drive letter, or mount, I should say. So that's pretty much all there is to it. I will post a link to this file in the description. It'll likely be on Gumroad, but it'll be free, this one. So go out, try it yourself, have fun. Let me know how it goes. Cheers.